So that's that. Now we have this training loop here. So
現実同士では拉致が開かない。サスケがつく読みを破った時点でもう 術戦は無意味だ。
じゃあここからは直接忍術のぶつかり合いってことだね。
イタチの左の万華鏡が最強の剣術を持つなら、右の万華鏡は最強の物理攻撃。アマテラスはその目が映したものを焼き尽くすまで消えない黒い炎と言われる。
出るかアマテラス。
早い、因を結ばせない気だ。
after we perform some available action in some other state. And again, we can be a little bit more precise about this, define actions, but it also state to us, slider possible action only valid in certain states and not in other states. And so that define a bit more mathematically, so to speak. So this will be a recurring theme, and we can more precisely define actions as a function. We're going to effectively define a function called actions that takes an input s, where s is going to be some state that exists inside of our environment, and actions of s is going to take this state as input and return as output the set of all actions that can be executed in that state. And so it's possible that some actions are only valid in certain states and not in other states. And we'll see examples of that soon too. So in the case of the 15 puzzle, for example, there are generally going to be 4 possible actions that we can do most of the time. We can slide a tile to the right, slide a tile to the left, slide a tile up, or slide a tile down, for example. And those are going to be the actions that are available to us. So somehow our AI, our program, needs some encoding of the state, which is often going to be in some numerical format, and some encoding of these actions. But it also needs some encoding of the relationship between these things. How do the states and actions relate to one another? And in order to do that, we'll introduce to our AI a transition model, which will be a description of what state we get after we perform some available action in some other state. And again, we can be a little bit more precise about this, define this transition model a little bit more formally, again, as a function. The function is going to be a function called result that this time takes 2 inputs. Input number 1 is s, some state, and input number 2 is a, some action. And the output of this function result is it is going to give us the state that we get after we perform action A in a little bit more formally, again, as a function. The function is going to be a function called result. It's some up that can be executed in that exists actions. What actions might we apply to that initial? Each of these states, any one of the agents like this in order to be, and what turns to make at what time, the correct sequence of actions that will take you from that initial state to the goal. And while this is a little bit abstract, anytime we talk about maze solving in this class, you can translate it to something a little more real world, something like driving directions. If you ever wonder how Google Maps is able to figure out what is the best way for you to get from point A to point B and what turns to make at what time depending on traffic, for example, it's often some sort of search algorithm. You have an AI that is trying to get from an initial position to some sort of goal by taking some sequence of actions. So we'll start our conversations today by thinking about these types of search problems and what goes into solving a search problem like this in order for an AI to be able to find a good solution. In order to do so, though, we're going to need to introduce a little bit of terminology, some of which I've already used. But the first term we'll need to think about is an agent. An agent is just some entity that perceives its environment. It somehow is able to perceive the things around it and act on that environment in some way. So in the case of the driving directions, your agent might be some representation of a car that is trying to figure out what actions to take in order to arrive at a destination. In the case of the 15 puzzle with the sliding tiles, the agent might be the AI or the person that is trying to solve that puzzle, to try and figure out what tiles to move in order to get to that solution. Next, we introduce the idea of a state. A state is just some configuration of the agent in its environment. So in the 15 puzzle, for example, any state might be any one of these 3, for example. A state is just some configuration of the tiles, and each of these states is different and is going to require a slightly different solution. A different sequence of actions will be needed in each one of these in order to get from this initial state to the goal, which is where we're trying to get. So the initial state, then, what is that? The initial state is just the state where the agent begins. It is one such state where we're going to start from. And this is going to be just the state where the agent is trying to get. So the initial state, then, what is that? The initial state is just the state where the agent begins. It is one such state where we're going to start from. And this is going to be the starting point for our search algorithm, so to speak. We're going to begin with this initial state and then start to reason about it, to think about what actions might we apply to that initial state in order to figure out how to get from the beginning to the end, from the initial position to whatever our goal happens to be. And how do we make our way from that initial position to the goal? Well, ultimately, it's via taking actions. Actions are just choices that we can make in any given state. And in AI, we're always going to try to formalize these ideas a little bit more precisely, such that we could program them a little bit more mathematically, so to speak. So this will be a recurring theme. And we can more precisely define actions as a function. We're going to effectively theme precise given state, what our goal happens to be. And how do we make our way from that initial position to the goal? Well, ultimately, it's via taking actions. Actions are just choices that we can make in any given state. And in AI, we're always going to try to formalize these ideas a little bit more precisely, such that we could program them a little bit more mathematically, so to speak. So this will be a recurring theme. And we can more precisely define actions as a function. We're going to effectively define a function called actions that takes an input s, where s is going to be defined. We'll then start to reason about it, to think about what actions might we apply. We're going to begin with this initial state, and then start to reason about it, to think about what actions might we apply to that initial state in order to figure out how to get from the beginning to the end, from the initial position to whatever our goal happens to be. And how do we make our way from that initial position to the goal? Well, ultimately, it's via taking actions. Actions are just choices that we can make in any given state. And in AI, we're always going to try to formalize these ideas a little bit more precisely, such that we could program them a little bit more mathematically, so to speak. So this will be a recurring theme. And we can more precisely define actions as a function. We're going to effectively define a function called actions that takes an input s, where s is going to be some state that exists inside of our environment. And actions of s is going to take this state as input and return as output the set of all actions that can be executed in that state. And so it's possible that some actions are only valid in certain states and not in other states. And we'll see examples of that soon, too. So in the case of the 15 puzzle, for example, there are generally going to be 4 possible actions that we can do most of the time. We can slide a tile to the right, slide a tile to the left, slide a tile up, or slide a tile down, for example. And those are going to be the actions that are available to us. So somehow our AI, our program, needs some encoding of the state, which is often going to be in some numerical format.
connections from the first layer to the second. The connections between the other layers also have a bunch of weights and biases associated with them. All said and done, this network has almost exactly 13,000 total weights and biases. 13,000 knobs and dials that can be tweaked and turned to make this network behave in different ways. So when we talk about learning, what that's referring to is getting the computer to find a valid setting for all of these many numbers so that it'll actually solve the problem at hand. One thought experiment that is at once fun and kind of horrifying is to imagine sitting down and setting all of these weights and biases by hand, purposefully tweaking the numbers so that the second layer picks up on edges, the third layer picks up on patterns, etc. I personally find this satisfying rather than just treating the network as a total black box, because when the network doesn't perform the way you anticipate, if you've built up a little bit of a relationship with what those weights and biases actually mean, you have a starting place for experimenting with how to change the structure to improve. Or when the network does work, but not for the reasons you might expect, digging into what the weights and biases are doing is a good way to challenge your assumptions and really expose the full space of possible solutions. By the way, the actual function here is a little cumbersome to write down, don't you think? So let me show you a more notationally compact way that these connections are represented. This is how you'd see it if you choose to read up more about neural networks. Organize all of the activations from one layer into a column as a vector. Then organize all of the weights as a matrix, where each row of that matrix corresponds to the connections between one layer and a particular neuron in the next layer. What that means is that taking the weighted sum of the activations in the first layer, according to these weights, corresponds to one of the terms in the matrix vector product of everything we have on the left here. By the way, so much of machine learning just comes down to having a good grasp of linear algebra, so for any of you who want a nice visual understanding for matrices and what matrix vector multiplication means, take a look at the series I did on linear algebra, especially chapter 3. Back to our expression, instead of talking about adding the bias to each one of these values independently, we represent it by organizing all those biases into a vector and adding the entire vector to the previous matrix vector product. Then as a final
最後の手裏剣でうまくいったな。
おかしい。
どうしたの？
いや、あんなものを避けきれないイタチではないはずだが。
さっきのつくよみの反動か？いい感じだな、おい。つくよみをしのいだ時点でサスケが戦いの流れを掴んでるね。さらにイタチの動きも鈍らせたし、この勝負サスケが勝っちまうかもよ。
いや、それはまだわからんぞ。
カトン強化球の術。この程度の傷じゃまだまだだ。 巻き添えを食うとこだった。
キャトン合格。
サスケの方が押してる。この戦いやっぱりサスケの。
アマテラス。
おお、出た。すげえ、炎で炎を食い尽くした。
あの術は燃やしたいところを目視し、ピントが合うだけでその視点から黒煙が発生する。黒煙は捉えたものを燃やし尽くすまで消えない。その対象が炎であってもだ。
Final step, I'll wrap a sigmoid around the outside here. And what that's supposed to represent is that you're going to apply the sigmoid function to each specific component of the resulting vector inside. So, meaningfully active. And that is just one neuron. Every other neuron outputs end up close to zero. Very positive integrated sum like this, you might come out then taking the weighted sum and other such things. Let's say the hope is for one particular neuron in the second layer to pick up on whether or not the image has an edge in this region here. The question at hand is, what parameters should the network have? What dials and knobs should you be able to tweak so that it's expressive enough to potentially capture this pattern, or any other pixel pattern, or the pattern that several edges can make a loop, and other such things?
What is up, boys? What is up? What is up?
because I wanted to be a theoretical physicist. And so I went to Princeton, and I was a really good student, as I pointed out already. I got A pluses on almost everything. I was in the honors physics track, which starts out with 100 students, and by the time you get to quantum mechanics, it's like 30. So I'm in quantum mechanics. I think this is like junior year, and I've also been taking a bunch of computer science classes and electrical engineering classes, which I'm also enjoying. And I can't solve this partial differential equation. It's really, really hard. And I've been studying with my roommate, Joe, who also is really good at math. And the two of us worked on this one homework problem for 3 hours and got nowhere. And we finally said, we looked up at each other over the table at the same moment. We said, Yosanta. Because Yosanta was the smartest guy at Princeton. And we went to Yosanta's room, and he was Sri Lankan. And in the Facebook, which was an actual paper book at that time, his name was 3 lines long, because I guess in Sri Lanka, when you do something good for the king, they give you an extra syllable on your name. And so he had a super long last name, the most humble, wonderful guy. And we show him this problem. And he looks at it, he stares at it for a while, and he says, cosine. And I'm like, what do you mean? He's like, that's the answer. And I'm like, that's the answer? And he's like, yeah, let me show you. So he brings us into his room. He sits us down. He writes out 3 pages of detailed algebra. Everything crosses out, and the answer is cosine. And I said, listen, Yosanta, did you just do that in your head? And he said, no, that would be impossible. 3 years ago, I solved a very similar problem, and I was able to map this problem onto that problem, and then it was immediately obvious that the answer was cosine. And that was an important moment for me, because that was the very moment when I realized I was never going to be a great theoretical physicist.
Person you have to spend the most time listening to in your life is yourself. Try not to lose.
We are part of a secret society dedicated to restoring freedom to the world. We are the Red Lotus. The idea of having nations and governments is as foolish as keeping the human and spirit realms separate.
You've had to deal with a moronic president and a tyrannical queen. Don't you think the world would be better off if leaders like them were eliminated?
No.
True freedom can only be achieved when oppressive governments are torn down. Do you know who once said, new growth cannot exist?
Audio capture, okay. Legend of Korra.
तुम्हारे पास तो केवल यही विकल्प है कि तुम क्या करो या क्या ना करो, परंतु परिणाम तुम्हारे वश में नहीं है पार्थ। कर्म फल तुम्हारे वश में नहीं है। तुम्हारे अधिकार की सीमा इस विकल्प पर समाप्त हो जाती है कि तुम युद्ध करोगे या नहीं करोगे, किंतु युद्ध का परिणाम तुम्हारे हाथ में नहीं है। यदि तुम विजय चाहो भी तो यह आवश्यक नहीं कि विजय तुम्हारी ही हो जाए, तुम्हारी पराजय भी हो सकती है। किंतु यदि तुम विजय से मोहित नहीं होगे तो पराजय से भी नहीं घबराओगे। यदि तुम ये सोचो पार्थ कि चाहे विजय हो चाहे पराजय, किंतु तुम तो केवल इसलिए युद्ध कर रहे हो कि युद्ध करना तुम्हारा कर्तव्य है, तो विजय के सुख या पराजय के दुख का प्रश्न ही नहीं उठता। विजय और पराजय, जीवन और मृत्यु, सुख और दुख के प्रश्नों में ना उलझो और युद्ध करो। यदि इस युद्ध में तुम्हारी विजय हुई तो पृथ्वी का राज्य और यश भोगोगे, और यदि वीर गति को प्राप्त हुए तब भी यश के साथ साथ स्वर्ग पाओगे। इसलिए हे कौन्तेय, उठो, सुख दुख, लाभ हानि, जय पराजय सबको समान समझो और युद्ध करो, कि यही तुम्हारा क्षत्रिय कर्तव्य भी है और मानव धर्म भी। और जो न विजय से सुखी हो और न पराजय से दुखी, वही स्थित प्रज्ञ है, यही कर्म योग है। तुम सर्वश्रेष्ठ धनुर्धर हो, परंतु यदि तुम्हारा आखेर तनिक भी इधर से उधर हो जाए तो तुम चूक जाओगे। तुम्हारा अधिकार तुम्हारे वाण संधान पर है, तुम्हारा अधिकार तुम्हारी दृष्टि पर है, परंतु उस मृग पर तुम्हारा कोई अधिकार नहीं जिसकी ओर तुम बाण चला रहे हो। हे धनंजय, सत्पुरुष कभी अपने अधिकारों की सीमा का उल्लंघन नहीं करते। अर्थात अपने कर्म में स्थिर रहो पार्थ, स्थिर रहो, क्योंकि कर्म की कुशलता का ही नाम योग है।
मेरा हाथ तो अब भी कांडी की ओर नहीं बढ़ रहा है केशव। मेरी समझ में तो अब भी ये नहीं आ रहा है कि इस युद्ध से लाभ क्या होगा।
तुम ये निर्णय केवल इसलिए नहीं ले पा रहे हो पार्थ कि तुम इस क्षण को केवल व्यक्तिगत लाभ और व्यक्तिगत हानि के तुला में तोल रहे हो। यही तो मोह का बंधन है पार्थ, यही तो तुम्हारे शोक की जड़ है, और इसीलिए तुम्हारा ये कायर, पलाय और कलंक में डुबोने वाला शोक न तुम्हारे हित में है और न ही समाज के हित में। यह शोक न वर्तमान के लिए शुभ है और न ही भविष्य के लिए। लाभ और हानि की इस कामना में न भटको पार्थ, न भटको, केवल कर्म करो, कर्म। हे पार्थ, सामान्य पुरुष विषय का ध्यान करता है, और विषय का ध्यान उसे आसक्त बना देता है। इस आसक्ति या लगाव से काम का जन्म होता है। जब काम की पूर्ति नहीं होती तो क्रोध उत्पन्न होता है। जब क्रोध उत्पन्न होता है तो विषय के प्रति मोह और बढ़ जाता है। और जब मोह और बढ़ जाता है पार्थ, तो सोचने की शक्ति भटक जाती है। जब सोचने की शक्ति भटक जाती है तो बुद्धि का नाश होता है। और जब बुद्धि का नाश होता है तो मनुष्य का सर्वनाश हो जाता है। और हे कुंती पुत्र, तुम्हारा ये मोह तुम्हें बुद्धि के विनाश की ओर ले जा रहा है। तनिक सोचो पार्थ कि जिसके पास बुद्धि ही ना होगी उसे शांति कैसे मिल सकती है। वो तो शांति और अशांति में अंतर ही नहीं कर सकता। और जो शांति को अशांति से अलग तक नहीं कर सकता, वो भला कैसे सुखी हो सकता है। हे पार्थ, जैसे पवन के झोंके नाव को भटका देते हैं, वैसे ही कामनाएं बुद्धि को भटका देती हैं। इंद्रियाणाम हि चरताम यन्मनो अनुविधीयते तदस्य हरति प्रज्ञाम वायुर्नवम इवाम्भसि। इसलिए हे महाबाहो, अपनी इंद्रियों को अपने वश में रखो, स्वयं ही उनके वश में न हो जाओ। पार्थ, ये बात ध्यान से सुनो और समझो कि जब संसार सोता है तब मुनि जागता है, और जब संसार जागता है तब मुनि सोता। हे पार्थ, ये भी न भूलो कि तुम एक महान पुरुष हो, और लोग तुम्हें दृष्टांत मानकर तुम्हारे पीछे पीछे काम और स्वार्थ के मार्ग पर चल पड़ेंगे, क्योंकि एक श्रेष्ठ व्यक्ति का आचरण तो दूसरों के लिए दृष्टांत बन ही जाता है। मुझे को लो। न मे पार्थास्ति कर्तव्यम त्रिषु लोकेषु किंचन नानवाप्तम अवाप्तव्यम वर्त एव च कर्मणि। त्रिलोक में मेरे लिए कुछ करना आवश्यक नहीं पार्थ, और त्रिलोक में ऐसा भी कुछ नहीं जिसे मैं प्राप्त करना चाहूं और प्राप्त ना कर सकूं। फिर भी मैं तुम्हारे सामने कर्म कर रहा हूं पार्थ, कर्म कर रहा हूं। ये दिखला रहा हूं, ये सिद्ध कर रहा हूं कि निष्काम कर्म के मार्ग पर चलते हुए जीवन व्यतीत करना संभव है। हे भारत, कर्म तो अज्ञानी भी करते हैं, परंतु केवल अपने निहित स्वार्थ की दृष्टि से। ज्ञानी का कर्म तो निस्वार्थ होता है, संसार के संतुलन को स्थिर बनाए रखने के लिए होता है, लोक कल्याण के लिए होता है। इसलिए हे पार्थ, अपने मन पर कोई बोझ न लो, अपना कर्म मुझे अर्पण कर दो और यह धर्म युद्ध करो। कर्तव्य पालन के मार्ग पर तो मृत्यु भी कल्याणकारी हो जाती है। यदि पितामह, गुरुजनों और सगे संबंधियों का तुम्हें वध भी करना पड़े, तब भी तुम्हें पाप नहीं लगेगा, क्योंकि कर्तव्य पालन पाप रहित होता है पार्थ। कर्तव्य पालन पाप रहित होता है। यदि वे वीर गति को प्राप्त हुए तो उनकी मृत्यु कल्याणकारी हो जाएगी, और यदि तुम वीर गति को प्राप्त हुए तो तुम्हारी मृत्यु। इसलिए हे पार्थ, युद्ध करो, क्योंकि धर्म का मार्ग पाप का मार्ग नहीं हो सकता।
पाप की बात निकल आई है तो ये बताइए किशन कि कभी कभी मनुष्य पाप करने के लिए इतना विवश क्यों हो जाता है? उसे कौन विवश करता है?
उसे विवश करती है उसकी वासना, उसे विवश करता है उसका निहित स्वार्थ, उससे पाप करवाता है उसका क्रोध, उसका मोह।
No care ever own what's mine when you're always
There is something I see in you.
How can you see into my
Be executing this code and just on, and then
into my core, where I become so numb,
which is the connection. So turns.
my spirit sleeping somewhere cold until you
And then we
but just watch out for that. You just use the dot view.
wake me up inside, wake up inside,
It's important to pay attention. Like alt, produce, so it's the outputs of each shape. Then
you can just leave me, breathe into me, make me real, breathe me wake me up inside, wake me up inside, call my name and save me from the dark, bid my blood to run before I come undone, save me from the nothing I've become.
नहीं चल रहा हूँ। कल टाइम से आ जाना भाई क्लास में, मैं शायद लेट हो जाऊँगा, सोता रह गया तो। वो कल बताएगा वो फाइनल प्रोजेक्ट का, वो तो कर देंगे वैसे उसका तो बहुत इजीली।
वो तो कर दोगे। वो प्रोजेक्ट पार्टनर आ रहा है अपना
भाई वो उससे पूछ, करता हूँ उससे बात, अभी कॉल करता हूँ उसको भी।
भाई तो डैलस में बैठे हैं।
अभी नहीं होगा भाई, आ गया होगा अब तो।
अभिषेक बता रहा था, अभिषेक से पूछना भाई तो एक बार उसके बारे में फिर।
अरे अभिषेक की, रुक जा एक सेकंड।
भाई तो एक बार उसके बारे में फिर।
अरे अभिषेक की, रुक जा एक सेकंड। अरे होगा उसको तो बताया, सोता रह गया तो। वो कल बताएगा वो फाइनल प्रोजेक्ट का, वो तो कर देंगे वैसे उसका तो बहुत इजीली।
वो तो कर दोगे। वो प्रोजेक्ट पार्टनर आ रहा है अपना
भाई वो उससे पूछ, करता हूँ उससे बात, अभी कॉल करता हूँ उसको भी।
भाई तो डैलस में बैठे हैं।
अभी नहीं होगा भाई, आ गया होगा अब तो।
अभिषेक बता रहा था, अभिषेक से पूछना भाई तो एक बार उसके बारे में फिर।
अरे अभिषेक की, रुक जा एक सेकंड।
My nigga, you got the senzu beans? All right, I'm gonna need some of that. You sure these are senzu beans?
A wanted criminal is on the loose. If you see any man who looks like this, please, I beg you, run for your life.
No, Goku wouldn't do anything like that. Goku, what's going on?
They charged me with a bunch of crimes. Destruction of property, vandalism, disorderly conduct,
Wow, that's...
extreme negligence, reckless speeding, indecent exposure.
That's a lot of...
Third-degree manslaughter, parking illegally, second-degree manslaughter.
I can't believe you were framed for all of that.
Framed?
Oh, Goku, how could you? Good for nothing.
You don't stop talking, they're adding murder to the charge. My nigga, you...
Do be sure to aim carefully, little lapdog. Despite being so woefully outmatched, there was a reason why your poor comrade's eyes were not completely glazed over with despair. It was because of the energy you hold in your paw, yes? By all means, please proceed at your leisure.
Well, here goes.
And that is acting.
You can!
She gets up and she says, Patrick, this is very hard for me to say this. And let me tell you why it's very hard. I said, what's that? She says, ever since in high school, I wanted to prove to men that I can beat them. So when I graduated high school and college, I opened up my salon. We do very well. I've made millions of dollars. My people and my work that work at the salon, they do very well for themselves. I drive a nice car. I have a nice house. I have money. I have millions. I don't worry about any of that stuff. You know what decision I made last night? I said, what's that? She says, I want a husband. I no longer want to compete with men. I need them. And I'm like, what? She's saying this in front of 2,000 people with her sister sitting right next to her. Wow. And now she's getting emotional. How many 65-year-old women do we have to hear saying that I marched with the feminist movement and I bought into the fact that men are the enemy? I've never been married. I'm alone and I'm miserable and I wish I would have never bought into that philosophy. She gets up and she says, Patrick, this is very hard for me to say this. And let me tell you why it's very hard. I said, what's that?
Vision Pros. Hell yeah, really fast. Help me out, dude.
If I gave you $500 to not talk to me, would you just walk the other way?
Yes, I would.
Here you go.
You're shitting me?
Nope. Thank you.
Oh, dope. It's a Vision Pros. Hell yeah, really fast.
All right. That's what we're here for, sir.
I'm gonna fuck you up my head.
Jesus.
If you could travel forever through eternity to the edge of infinity, what else is there left to learn?
Maybe just a new infinity.
I'm gonna say death. I'm gonna say death. I'm gonna say death. I'm gonna say it's a trick question. Death. What?
Doing belt the squats by accident. Wait for it.
Oh! I got my belt.
So even though research has shown a weightlifting belt can help you lift heavier weights with more explosive power, there's still 2 rules that you should follow when using one. Rule number 1, you don't wear your weightlifting belt for every single set, especially your warm-ups. This is Lee Sang, a South Korean weightlifter going through some deadlifts. You'll notice he's not going to put his weightlifting belt on until his heaviest sets. Let me tell you the reason for that in a second. Rule number 2, you still have some programmed heavy lifts within your training without a belt, like this no belt pause squat that Lee's performing here. Excellent technique. You see, even though a weightlifting belt can be helpful at increasing intra-abdominal cavity pressure and therefore stability, we never want to lose sight of an
format and some encoding of these actions, but it also needs some encoding of the relationship between these things. How do the states and actions relate to one another? And in order to do that, we'll introduce to our AI a transition model, which will be a description of what state we get after we perform some available action in some other state. And again, we can be a little bit more precise about this, define this transition model a little bit more formally, again, as a function. The function is going to be a function called result that this time takes two inputs. Input number 1 is S, some state, and input number 2 is A, some action. And the output of this function result is it is going to give us the state that we get after we perform action A in state S. So let's take a look at an example to see more precisely what this actually means. Here's an example of a state of the 15 puzzle, for example. And here's an example of an action, sliding a tile to the right. What happens if we pass these as inputs to the result function? Again, the result function takes this board, this state, as its first input, and it takes an action as a second input. And of course, here, I'm describing things visually so that you can see visually what the state is and what the action is. In a computer, you might represent one of these actions as just some number that represents the action. Or if you're familiar with enums that allow you to enumerate multiple possibilities, it might be something like that. And this state might just be represented as an array or two-dimensional array of all of these numbers that exist. But here, we're going to show it visually just so you can see it. But when we take this state and this action, pass it into the result function, the output is a new state. The state we get after we take a tile and slide it to the right, and this is the state we get as a result. If we had a different action and a different state, for example, and pass that into the result function, we'd get a different answer altogether. So the result function needs to take care of figuring out how to
Me and my father, we watch your fight, but you make me a little bit upset.
You caused almost a couple fights in my house growing up.
I remember 23rd February 2003. You supposed to fight with Clifford Etienne.
My dad would get the pay-per-views.
And I remember it's supposed to fight like 5 morning in Moscow time. And I told my father, please, can you make me wake up? I really want to watch this fight. Me and my father, we watch your fight, but you make me a little bit upset because you knock him out in first round. I was waiting for this. I was waiting for this all night.
The fight's about to start, and my dad's like, okay, I'm gonna go. I think he went to go get a beer in the garage. He has his friends all in the living room, and my dad goes in the garage, and he comes back. Fight's over. My dad.
Me and my father.
John Jones put a fan in the hospital. Do you guys know about this? There was some J Brown called Sneakers that went and did this with John Strickland 2 weeks ago. John warns him a few times. Boy, he does it nice. John Jones was trying to be nice. He came to great concern, one, that he was the level of wimp that needed a hospital overlay. I mean, not for nothing. You put some ice on it, or better yet, you don't do anything. The fact that we know it is a concern for me. You don't want that kind of attention unless you're that kind of guy. If you're that kind of guy, yeah, of course, a lawsuit's next. John Jones, put a...
You only eat meat still?
Yep.
Talk me through a day's diet.
Strip loin. Strip loin steak, that's
So you
about
wake up in the morning, what do you have for breakfast?
Strip loin.
What do you have for lunch?
Strip loin.
What do you have for dinner?
Sometimes strip loin in soup.
You have 3 steaks a day? That's
Yeah,
it.
yeah.
No
Right,
vegetables or anything? You just...
Nope.
Nothing, just a steak?
Yeah.
Do you have any sauce?
No.
I mean, it's kind of fascinating. How long have you done this? 6 years?
Yeah, 6 years in December.
You look like you're bursting with good health. I mean, what do the experts say about this?
Depends on the experts, but mostly, you know, you should have died by now is usually the reaction I get.
You only eat meat still?
Would you rather date a female UFC fighter or an model?
Most of the UFC girls are like very like tomboyish and into girls. They're not like like most women are, feminine women. So I would probably definitely take the UFC girl just because that's like a real job and like a real profession and career. And nothing against like, but like it's just you're selling yourself to the world. Like it would be tough to.
Have you ever been fingered by an MMA fighter before?
You asked me if an ordinary person, by studying hard, would get to be able to imagine these things like I imagine. Of course, I was an ordinary person who studied hard. There's no miracle people. It just happens they got interested in this thing, and they learned all this stuff. They're just people. There's no talent, a special miracle ability to understand quantum mechanics or a miracle ability to imagine electromagnetic fields that comes without practice and reading and learning and study. So if you say you take an ordinary person who's willing to devote a great deal of time and study and work and thinking and mathematics and time, then he's become a scientist.
There's a small subset of the people that can be very happy being obsessive about things. And, obsession can often get things done that just practical, prudent, pedestrian work won't, or at least won't for a very long time.
But I do think that great things require a lot of hard work. So there's no way you can expect to change the world without working really hard. And by the way, even changing the world, the folks that I respect the most have nudged the world in like a slight direction. Slight. Very, very slight. I think to have great outcomes, you actually do need to work at like 3 standard deviations above the mean. But when I read about companies going to like 4-day work weeks and stuff, I chuckle because I can't get enough done with a 7-day week. I don't know how, and people will say, oh, you're just not working smart. And it's like, no, I work pretty smart, I think, in general.
And I think the focus should be more like how much you do. So I am kind of like believer on a high level in this 10,000 hours kind of concept where you just kind of have to just pick the things where you can spend time and you care about and you're interested in. You literally have to put in 10,000 hours of work. It doesn't even like matter as much like where you put it, and you'll iterate and you'll improve and you'll waste some time. I don't know if there's a better way. You need to put in 10,000 hours. But I think it's actually really nice because I feel like there's some sense of determinism about being an expert at a thing if you spend 10,000 hours. You can literally pick an arbitrary thing, and I think if you spend 10,000 hours of deliberate effort and work, you actually will become an expert at it. And so I think it's kind of like a nice thought. And so basically I would focus more on like, are you spending 10,000 hours? One other thing that I think is helpful for the psychology of it is many times people compare themselves to others in the area. I think this is very harmful. Only compare yourself to you from some time ago, like say a year ago. Are you better than you a year ago? This is the only way to think. And I think then you can see your progress, and it's very motivating. You will waste time doing something wrong.
Yes.
You will eventually figure out it's not right. You will accumulate scar tissue. And next time you'll grow stronger because next time you'll have the scar tissue, and next time you'll learn from it. And now next time you come to a similar situation, you'll be like, oh, I messed up. I've spent a lot of time working on things that never materialize into anything. And I have all that scar tissue, and I have some intuitions about what was useful, what wasn't useful, how things turned out. So all those mistakes were not dead work, So I just think they should just focus on working. What have you done? What have you done last week?
10,000 fucking hours, man, on Rega Party. Why not you? Why not you? Why not you? wasting passe every day. Je hoop, il y a beaucoup.
Which is going to generate tokens for us. So we pass an index, which is the current index or the context, and then we have max new tokens, and this is passed in through here. So we have our context, we make it a single zero, just the next line character, and then we generate based on that, and then our max new tokens second parameter, we just make it 500 second parameter. So cool. what do we do inside of here? We have a little loop that pretty much it generates based on the length of, or the range of the max new tokens. So we're going to generate max new tokens, if that makes sense.
Many years ago, the great British explorer George Mallory, who was to die on Mount Everest, was asked why did he want to climb it. He said, because it is there. Well, space is there, and we're going to climb it. And the moon and the planets are there, and new hopes for knowledge and peace are there. And therefore, as we set sail, we ask God's blessing on the most hazardous and dangerous and greatest adventure on which man has ever embarked.
Don't just aspire to make a living. Aspire to make a difference.
You do physics not because it's easy, but because it's hard. The system of life rewards tenacity, rewards your urge to tackle something you've never seen before and succeed. And even if you don't succeed in that tenacity, to have the energy to go back and try it again. Knowing how to fail. These are things that the most successful people have going for them. Take classes because they're hard, not because they're easy. For every hard thing you accomplish, you ascend a pyramid. And every next rung that you ascend, you look around and there are fewer people at that level. That's what it means to do something that's hard. Fewer people can do it. Only by doing hard things do you ever distinguish yourself from others around you. It's not good enough to only be smart at something or to score high on an exam. At some point, you have to step away from the exam and say, I have a new thought that no one has had before.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills. Because that challenge is one that we're willing to accept. One
This is why I don't think that we should be together. And I've thought about it a lot, and this is what's gonna happen. Okay, I'm gonna keep pursuing what I'm pursuing. And because I'm doing that, it's going to take up more and more of my time, and I'm not going to be able to spend as much time with you. And even when I do spend time with you, I'm going to be thinking about drumming. And I'm going to be thinking about jazz music and my charts and all that. And because of that, you're going to start to resent me. And you're going to tell me to ease up on the drumming, spend more time with you because you're not feeling important. And I'm not going to be able to do that. And really, I'm just going to start to resent you for even asking me to stop drumming. And we're just going to start to hate each other. And it's going to get it's going to be ugly. And so for those reasons, I'd rather just, break it off clean. Because I want to be great. One, two, three. 1, 2, 3.
Say it louder!
I'm upset!
Carl. Start practicing harder, Neiman.
They were school buddies, am I right? Charlie Parker didn't know anybody until Joe Jonas threw a cymbal at his head.
So that's your idea of success, huh?
I think being the greatest musician of the 20th century is anybody's idea of success.
Dying broke and drunk and full of heroin at the age of 34 is not exactly my idea of success.
I'd rather die drunk, broke at 34 and have people at a dinner table talk about me than live to be rich and sober at 90 and nobody remember who I was.
They say I'm too young to love you. I don't know what I need. They think I don't understand the freedom land of the 70s. I think I'm too cool to know ya. You say I'm like the ice I freeze. I'm churning out novels like beat poetry on unfitted memes. I say well, my boyfriend's in a band. He plays guitar while I sing lyrics. I've got feathers in my hair. I get down to be poetry. And my jazz collection's rare. I can play most anything. I'm a Brooklyn baby. I'm a Brooklyn
Hey guys, how you doing? So, in this video, we're going to go over what the NVIDIA CEO said about coding. He basically said, don't learn to code. Coding has no future. So being an old-time coder, I scratched my head and said, wait a second, that's weird. So let me just cut to the chase. And based on my 3 decades of experience in the field, so first of all, no, software development and coding is not going away. It's just going to change. And this has happened several times before. And I'm going to give you some examples where a new technology emerges, and then people out there are going, oh my God, it's the end of the world. That's it for the profession, blah, blah, blah. And it doesn't happen. So I'm going to give you a bunch of examples that are fairly recent. And I think that will help you in terms of if you have any fears about this. So my final comment, I'll just give you a final comment before I go into the details. This is what I've been saying for years. Concentrate on the fundamentals, learn to build things. So learn the foundations of code, and then learn to build things, start building things as quickly as possible. You don't want to get stuck in tutorials. You got to learn soft skills, educational skills, organizational skills. These are all super important, especially in the age of AI and prompt engineering, as they say. But this has been hugely important in the past, for sure. So the elite developers of today and the past had this range of skills that I talked about just now. So let me just jump into it. So the NVIDIA CEO says coding has no future. So why would he say this? So first of all, let's talk about coding versus development. This video is sponsored by Porkbun, a domain name registrar. They got a huge selections of .coms, .food, .it, .inc for you to choose from. They are ranked #1 on USA Today. They got the top score on Trustpilot with 4.8 stars, over 9,000 reviews. The reason to use Porkbun, besides the fact you can trust them, is that each domain comes with a free Who Has Privacy. Other places you got to pay for that. Free SSL certificate, URL forwarding, and email forwarding. As you can see here, Porkbun has a large range of domain name extensions from .academy, .agency,
Jensen Huang, co-founder and CEO of NVIDIA, the company that is at the heart of the AI revolution, recently made a comment about what kids should learn in the future. And let me spoil it to you, it's not computer science or programming.
I'm going to say something and it's going to sound completely opposite of what people feel. You probably recall, over the course of the last 10 years, 15 years, almost everybody who sits on a stage like this would tell you it is vital that your children learn computer science. Everybody should learn how to program. And in fact, it's almost exactly the opposite. It is our job to create computing technology such that nobody has to program. Jarvis, you up? And that the programming language is human.
At SimFminds, a full-service AI agency where I'm a co-founder, we're in a close relationship.
Wait a minute.
Relationship with NVIDIA. And later in this video, I will We'll include a clip of what Jensen said people should study, which is also in alignment why we're expanding our team with people like Amy.
Air Force, etc., and so on. You can also see that they have a lot of sales. For example, .cash, first year sale, more than 50% off. So with Pork Bun, you have a building software-based solutions. So that, well, part of that is coding, but a big part of it is also understanding the landscape in terms of technologies that you have. You have to have those nerd eyes, as I call them, the ability to discern what's out there, to be able to pick and choose what is best. So I'll give you a very concrete example. Something very simple. You're putting up a web store for some local small business, a coffee shop. I like using coffee shops as an example. So a coffee shop. So you got to decide, okay, you got to build the branding site. You got to pick the right photography. You got to put the right copy in, static web, third party type of what kind of data. Bloody e-commerce presence for a local business. Just when you're dealing with the branding end of a website, that requires good marketing knowledge, domain knowledge. They talk about that in AI, something I've been talking about for years and years now. So you got to figure out, okay, this is the coffee store. What kind of simple project, just putting up a bloody e-commerce presence for a local business. Just when you're dealing with the branding end of a website, that requires good marketing knowledge, domain knowledge. They talk about that in AI, something I've been talking about for years and years now. So you got to figure out, okay, this is the coffee store. What kind of coffee are they selling? What's the competitor? What's their advantage in the marketplace? How do we present that in the website itself? How do we present that? What type of images are we going to use? Close to that. People were talking about on the news how, oh my God, truckers, they're dead, the self-driving trucks, it's over, all those truckers are going to be out of business. Didn't happen. Many years later, what is it, 7 years later, whatever it is now, it's not even close to that. It's not even close. Don't get me wrong, self-driving is great. My self-driving vehicle, it's not as good as Tesla. It's the Genesis, so it's the high-end Hyundai. You know, I decided to get rid of my German cars because I didn't want to go to the shop every 2 minutes. But anyway, self-driving car.
You have arrived at a developers conference. There will be a lot of science described, algorithms, computer architecture, mathematics. Blackwell is not a chip. Blackwell is the name of a platform. People think we make GPUs, and we do, but GPUs don't look the way they used to. This is Hopper. Hopper changed the world. This is Blackwell. It's okay, Hopper. 208 billion transistors, and so you could see, I can see, there's a small line between two dies. This is the first time two dies have abutted like this together in such a way that the two dies think it's one chip. There's 10 terabytes of data between it, 10 terabytes per second. So that these two sides of the Blackwell chip have no clue which side they're on. There's no memory locality issues, no cache issues. It's just one giant chip. And it goes into two types of systems. The first one is form-fit-function compatible to Hopper. And so you slide on Hopper and you push in Blackwell. That's the reason why one of the challenges of ramping is going to be so efficient. There are installations of Hoppers all over the world, and they could be the same infrastructure, same design, the power, the electricity, the thermals, the software, identical, push it right back. And so this is a Hopper version for the current HGX configuration. And this is what the second Hopper looks like this. Now this is a prototype board. This is a fully functioning board, and I'll just be careful here. This right here is, I don't know, $10 billion. The second one's 5. It gets cheaper after that. So any customers in the audience, it's okay. The Grace CPU has a super fast chip-to-chip link. What's amazing is this computer is the first of its kind where this much computation, first of all, fits into this small of a place. Second, it's memory coherent. They feel like they're just one big happy family working on one application together. We created a processor for the generative AI era. And one of the most important parts of it is content token generation. We call it, this format is FP4. The rate at which we're advancing computing is insane, and it's still not fast enough, so we built another chip. This chip is just an incredible chip. We call it the NVLink switch. It's 50 billion transistors. It's almost the size of Hopper all by itself. This switch chip has 4 NVLinks in it, each 1.8 terabytes per second, and it has computation in it, as I mentioned. What is this chip for? If we were to build such a chip, we can have every single GPU talk to every other GPU at full speed at the same time. You can build a system that looks like this. Now this system is kind of insane. This is one DGX. This is what a DGX looks like now. Just so you know, there are only a couple, 2, 3 exaflops machines on the planet as we speak. And so this is an exaflops AI system in one single rack. I want to thank some partners that are joining us in this. AWS is gearing up for Blackwell. They're going to build the first GPU with secure AI. They're building out a 222 exaflops system. We're CUDA accelerating SageMaker AI. We're CUDA accelerating Bedrock AI. Amazon Robotics is working with us using NVIDIA Omniverse and Isaac Sim. AWS Health has NVIDIA Health integrated into it. So AWS has really leaned into accelerated computing. Google is gearing up for Blackwell. GCP already has A100s, H100s, T4s, L4s, a whole fleet of NVIDIA CUDA GPUs, and they recently announced the Gemma model that runs across all of it. We're working to optimize and accelerate every aspect of GCP.
भाई मेरी गांड फट गई है क्या चल रहा है भाई दुनिया में
Data annotation, great experience so far. No question about it.
I've worked on the data annotation.
Way to dabble in it.
Wow.
Jack Madalena. $1.8 trillion parameters. What the fuck, bro? Okay, so context is 3. Target YT, so target is 7. Correct. Second iteration. T equals to third iteration. भैया 3 iteration है कि what इधर? अरे यार भैया जब मैं दिमाग लगाना चालू करता हूँ तभी अटकना होता है इसको. क्या हो गया भाई? Okay. First we create 2 sequences given for the train data is ठीक है. Block size is 3. Train data is 1 से चालू होगा. 0 1 0 1 2 3 तो 1 2 7 5 2. Block size plus 1. Block size plus 1 is 7 5 2. Okay. Sequential loop. Now we will go through each number in our block size of 3. For each step we will pick number from x and the corresponding number from y. The loop 40 in range block size will run 3 times because our block size is 3. Okay. Here how the loop would use our number. First iteration t equal to 0, context equals to x of t, so context is 3. Target is y of t. So target is 7. Huh? 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 What code did I give it? Oh, I think I gave it this code. No, it's fine only. Fucking hell, bro. हाँ भाई क्या कर रहे हो?
Well, what we'll do is assign a weight to each one of the connections between our neuron and the neurons from the first layer. These weights are just numbers. Then take all of those activations from the first layer and compute their weighted sum according to these weights. I find it helpful to think of these weights as being organized into a little grid of their own, and I'm going to use
विजय और पराजय, जीवन और मृत्यु, सुख और दुख के प्रश्नों में ना उलझो।
अबे तो बहन चोद करके देखता हूँ आ गया कॉन्सेप्ट समझ आ गया आ गया आ गया कॉन्सेप्ट समझ में आ गया आ गया एक बंदा नहीं आया आज तो चलो गाइस यहीं पे समाप्त कर रहा हूँ मैं आज कॉन्सेप्ट समझ आ गया मेरे को ये 3 घंटे लग गए बट समझ आ गया Fuck that शोध कल